mechanisms underlying microbial-mediated changes in social behavior in mouse models of autistic spectrum disorder, or we're going to say ASD later on. So these mice that are models of autism, and we'll go into that later. So here's the general. I apologize for the incorrect sequencing, but we're going to go background, hypothesis, methods, results, conclusions. You get it. All right.
There is an influx of new research coming out and unveiling the direct connection between the gut microbiome and mood, neural disorders, obesity, body composition, immunity, metabolic phenotypes, and more.
These images are going to touch base on it more, but obviously you can see this is the human gut, right? This is the brain, and this image is actually going to be touched more on now. So we have the gut microbiome, right? It can influence brain function. As you can see here, this arrow represents the brain influencing the gut microbiome, right? And this is due to the endocrine system. So you can see these are for instance androgens, estrogens. I kind of have trouble pronouncing these, and progestins, endocrine disruptors, right? So this is influencing the gut, while also simultaneously going backwards, right? It also influences the brain itself. So you have neurotransmitters, right? Be it dopamine, serotonin, right? First they get transferred to the circulatory system, and then that itself goes back to the brain, and it can influence stress, cognition, mood, emotion. Yeah.
All right, so this is some of the background for this niche topic itself. Gastrointestinal problems have been associated with changes in the microbial communities inhabiting the guts of autistic individuals. Previous studies of maternal high-fat diet, or MHFD, and obesity in mothers shows a 1.5 times increase in the probability of the offspring having autism. And in mice models, we can see that there is a decrease in the bacteria L. reuteri. Some people pronounce it L. reuteri, but I'm going to say L. reuteri for this example in mice. And so that's what we're really going to touch on here. We're going to go into it more. And remarkably, treatment with L. reuteri significantly improved sociability and preference for social novelty in MHFD offspring. So in these offspring, they had a hard time, they had social deficits. So in some of the examples we're going to show, it's going to be one of the tests is a matter of an interest in an empty cup or a novel mouse, a mouse they do not know. And some of the social deficit mice, or the MHFD offspring, in the previous study, would go to the empty cup with the same interest as the novel mouse. But as we'll talk about soon, wild-type mice, or analogous to humans, or neurotypical humans, would find more interest usually in the new mouse, or for us, new person. And then here's a graph, the identified prevalence of ASD, and this is from the CDC, so I just wanted to share what brought this importance to our mind and why more studies are coming out in regards to the gut microbiome. And in fact, children with ASD are 3.5 times more likely to suffer from GI disorders than children without developmental disorders.
Rudimentary intervention will be capable of reversing social deficits observed in mouse models of ASD, irrespective of the specific cause or model of the disorder. And we are finding out does L. reuteri have an impact on social deficits and ASD models of mice.
And then also in the study, they go on to branch off of how the mechanisms in which it does that. Because there are two different mechanisms for which the gut-brain axis connect. There's one through the vagus nerve, and then there's one where there's a permeability level in the gut. Maybe you guys have heard of leaky gut, where parts of the gut and toxins come out and spill into the bloodstream, and then that's how it would get connected in turn. So we see that there's a lot of issues with ASD and gut microbiome. So they initially tested, maybe it's because they have a more permeable gut, and we'll go into how they disprove that a little later.
Okay. And just a means of clarification, right? The previous research that was done regarding L. reuteri, it was done in mice without ASD. So the only difference now is that we're testing it with mice, on mice with ASD to see whether or not it would have a significant effect on their socioeconomic. So let's begin.
Okay, I'll share this. Mice, okay, so I'm gonna have a hard time with this pronunciation, so please forgive me. Mice lacking the SHANK beta isoform of the SHANK3 gene exhibit ASD-like behaviors, including social deficits. Given that individuals with ASD often show changes in their gut microbial ecology, or their gut microbiome, do SHANK3B mice display alteration of their gut microbial composition? And so, in this presentation, we're going to go over the 3 different models they had, and this one being the first model and the more predominant one in which they used to do studies. So we could kind of look at this in the unprofessional sense as the autistic mouse model.
So recent finding, right? So recently in mice, researchers have found that maternal high-fat diet, MHFD, induces social deficits and a change in the gut microbiota of offspring that is characterized by a reduction of alveoli. Consistent with this data, HFD-induced obesity in adult mice also leads to a reduction in the levels of alveoli. More importantly, selective treatment with alveoli versus the social deficits in MHFD offspring.
So the big reason we talk about this is to show a little bit of the background and why we think this is so promising, because it's been proven in other models, not ASD models, but more, I guess, mechanically induced social deficits. And so we're trying to see in the sense of a case like autism, where even if we don't know the origin, and as we said earlier, irrespective of the cause or origin, can this still have an impact?
Okay, and just to briefly,
What's it?
All the time.
Okay, go on.
wait, is the mic the top one?
Yeah, that's the top. That's the.
They look great.
Okay, do you want to explain this?
Well, you want to explain it?
Alright, so this is basically just a summary of the mechanisms of maternal obesity. As you can see, so we start here, right, the altered nutrients, neurotransmitter exposure, behaviors, and we go here to reduce the MCD. We'll touch more on the technical, complicated terms later, but this is just like the general overview of it.
Wait, the more important part is I just shared about this. So this is how the maternal high-fat diet mice kind of issues. There's more intestinal permeability, and that's associated with the increased adiposity or increased level amounts of fat that these mice have. They are coinciding with each other, both issues.
Do SHANK3 mice have a different gut microbiome? To answer this question, the researchers performed 16S ribosomal RNA gene sequencing on fecal samples from SHANK3B mice and wild type WT.
Yeah, well, all right, so I'm just going to speed through this because we're going to extrapolate on it in the next few slides. But each of the figures have like 8 points on it, so I'm just going to share each one. So A, right here, the principal coordinates analysis of unweighted unifrac distances from the 16S RNA gene sequencing dataset, and then the bulletin board, shows that SHANK3B samples differed from those of wild-type littermates. So their microbiome was different. That has been established by this. And then B, the PCR analysis shows lower levels of L-reuteri in SHANK3B mice. And then C is a schematic of the experimental design. So I'm going to touch on it right now and go deeper on it later. So they gave the SHANK3B mice 3 weeks after they were born for 4 weeks, the L-reuteri in the water they were drinking, low levels, and they tested the sociability before and after. And then this is the sociability test D. And so sociability is the empty cup versus novel mouse example I showed. And then social novelty is, I believe it was a mouse they knew versus a new mouse.
Alright, so E and F, the alveoli rescued the social behavior deficits in the 3-chamber test, and you can see that. So this is the empty, and this is the empty mouse 1, right? This is all their data.
The key right there on the right.
So this is WT, right? The Shank 3B plus the vehicle, right? And the vehicle is they're the ones that receive the outright within the water.
I had a hard time with this.
Yeah, it was
The way it wasn't super clear because I know the Illinois group they got it through means of water. I don't know if the vehicle was through means of injection.
So vehicle just means what was the bacteria in.
Okay.
So it's just water.
Okay.
So the vehicle is water.
Okay. I
So
see.
the vehicle is just, what that means is if it's a drug, it's what the drug is dissolved in.
Okay.
Right? So it could be saline or water or whatever, so the vehicle is just.
Oh, I see.
That's it. So that's why, again, it's kind of you need that control, so you're not, any effect you're getting is not due to the water, or
Okay.
not due to the vehicle, right? That's due specifically to the drug.
That's why I talked about sham. Right.
And then the blue represents the Shank 3B plus the L-redorai. So you can see the L-redorai for here, right? It's significantly high. And it did rescue the social behavior deficits. For this one, kind of the same concept, although you can see this is kind of normally, not really normally distributed, but I mean it's a bit more even than E. You go to G, the schematic of the reciprocal social interaction task. This actually kind of confused me. I'm not necessarily sure like what this is supposed to represent, unless y'all want to touch base on that.
I'm not so sure about the details of the reciprocal social interaction because I guess that was something I should have known prior. But I do see the results on the right, and it seems as though the L-redorai did have an effect. I'm sure this has something to do with social interaction or how much they reciprocate one's interaction with another. And so we do see that it did have a substantial effect in that way. Or significant,
To examine whether reduced L-redorai levels in the gut of Shank 3B mice could account for social behavioral deficits. Shank 3B mice were treated with either vehicle or L-redorai added daily in drinking water for 4 weeks. To test social ability, they compared the time that the experimental mouse spent interacting with either a stranger mouse, mouse 1, or an empty water cup. As expected, the WT mice displayed normal sociability as reflected by their preferential interaction with stranger mouse. By contrast, Shank 3B mice showed no preference for the stranger mouse over the empty cup.
So this is all demonstrated here.
So it's the same way that you'll see an iPad kid choose to be with their iPad over, I guess, speaking to another child or something more extreme of that matter is analogous to this social novelty test or
Yeah.
social ability test.
And that's the reason as to why the mouse, I don't know if you guys can see, but their ears, right? Facing the mouse instead of the empty cup. Why? Because their social ability levels increased and with social novelty.
What I deduced and what I read, and I believe I read, I didn't really internalize this point. Social novelty was like a litter mate versus a stranger mouse. A litter mate is like a peer in their litter.
Alright, so we have the results. So the treatment with L-redorai did rescue sociability within Shank 3B mice. Indeed, the performance of L-redorai treated Shank 3B mice was similar to that of WT controls that's shown in this figure. To further support these findings, the researchers next assessed reciprocal social interaction by measuring the amount of time that stranger genotype and treatment matched mice spent interacting as peers. So the Shank 3B mice interacted significantly less with WT litter mates, and treatment with L-redorai reversed
can see here, when you point to the graph, the vehicle mouse, so that's just a regular shank 3 mouse that's drinking some water, obviously has a difference relative to the L. rotari shank 3 mouse and the wild type littermate. And as we can see here that they didn't really share on, perhaps there's a reason that I'm not too familiar with, it seems that the L. rotari gave the shank 3B mouse an advantage or maybe extra interaction time over the wild type mouse. So perhaps there was too much of an extreme effect that it went completely on the other end of the spectrum, no pun intended. And so this was one of the other mouse models of ASD that they had. It was BTBR mice show alterations in the composition of the gut microbiota, and treatment with L. rotari rescues their social deficits. So the main point of using this mouse, I believe it was some sort of inbred mouse. Yes, inbred mouse line was just to show that this was not the only ASD model with an altered gut microbiota, and so they just wanted to show that the gut microbiota was a universal thing across not only ASD individuals, as we've seen, but ASD mouse models to prove the similarity between the mouse model and the human model. Well, not human model, but individual. And they found a reduction in L. rotari in the BTBR mouse. Their gut microbiome was not only different, but different in that exact manner. And it was effective for them as well. As we can see through this graph I made too small.
Yeah, but this basically is the sociability, this is the social novelty, and this is the reciprocal social interaction. So basically, same graphs as you guys saw before, although the dots were, WT, right? They're significantly higher, or the highest rather, for like sociability. And they actually maintain that only until you get to reciprocal social interaction, whereby the L. rotari, BTBR, is the highest. So you can see the effect of the L. rotari again.
Okay, and I know this is a lot of words, but I'll try to summarize it. So to finally, they wanted to now know the effect in which it did, because gut-brain axis is one thing, is it Bluetooth, are they talking to each other, how and which are they doing that? So they asked whether L. rotari exerts its effects on social behaviors directly or indirectly by correcting the altered microbial composition of the host. They first analyzed this composition of the gut microbiota in vehicle-treated and L. rotari treated shank 3B mice as determined by the same gene sequencing as before, and it was found that treatment with L. rotari did not significantly alter the gut microbiome of either the shank 3B ASD model mouse or the BTBR ASD model mouse. Hence, contrary to what was maybe assumed, L. rotari has no significant impact in the overall microbial composition of the host.
So there's a catch.
The underlying mechanism. L. rotari reverses deficits in social behavior via the vagus nerve. So they wanted to know how much it did and how much L. rotari exerts its effects on social behaviors directly or indirectly, and they did it by correcting the altered microbial composition of the host. Okay, so the researchers first asked whether L. rotari exerts its effects on social behaviors directly or indirectly by correcting the altered microbial composition of the host. To answer this question, they first analyzed the gut microbiota, as we said before, and it was found that treatment with L. rotari did not significantly affect it, as we said. Okay, I guess this is a copy and paste of the last slide. And so, as I said earlier, shank 3B mice show no alterations in intestinal permeability, and L. rotari fails to improve social behavior in vagotomized shank 3B mice. And I'm going to share what that means in the next slide. So to determine whether the vagus nerve is required for L. rotari to reverse the social deficits in shank 3B mice, the researchers performed, I'm not so sure of the correct pronunciation, vagotomy in these mice. Control mice, sham-operated mice, the vehicle mice, underwent the same surgical procedures except that the vagal branches were not transected. If the vagus nerve is required for relevant gut microbiota brain communication, L. rotari should fail to rescue the social deficits in vagotomized shank 3B mice.
So we can see how Alright itself, it's not significant enough to yield these changes, and we're actually going to, it's like we're building up, we're going to eventually explain
I'm
what it
going,
is.
I'm going to explain this figure. So it's consistent with this hypothesis. We found that L-Motorite rescued social behaviors in the sham-operated, but not in the vigoromized SHANK3B mice, which I wasn't 100% sure of how the process of vigotomy was executed, but I know there was a block in communication with the vagus nerve. So they snipped the vagus nerve, and so the mice no longer had the improvement with the L-Motorite, which goes to show the mechanism in which it was doing so was through the vagus nerve, because once they removed it, it also removed the effects.
And this obviously explains the reason as to why the dots are more higher on the scale, they have more interaction time. The dark blue dots, they represent the sham, SHANK3B with the L-Motorite, and the vagotomized SHANK3B with L-Motorite obviously have like lower interaction time, so you can see the effect of that plays. Yeah, so this is basically the secret, I guess. So oxytocin actually rescues social behavior deficits and genetic, environmental, and idiopathic models of ASD. So oxytocin actually modulates numerous aspects of social behaviors. When you think of oxytocin, just think of like love, right? So it makes you like more like susceptible to like, I guess like bond with others or like be like more social, right? So treatment with oxytocin reverses social deficits in several mice models of ASD. Additionally, it's known that vagal nerve fibers project to the PBN, a brain region where oxytocin is produced, and that the wrong activity in the PBN induced by bacterial colonization is blocked by vagotomy. Finally, the stimulation of vagus nerve promote oxytocin release.
And as we can see here, as expected, L-Motorite treatment increased both the number of fluorescence intensity of oxytocin-positive neurons in SHANK3B mice. So it it goes to show that L-Motorite has a causation on the production, or is it proper terminology secretion?
I think they're just measuring the amount of oxytocin in the brain.
So L-Motorite increases the amount of oxytocin in your brain, as we see by this figure.
Some or the conclusions. One, traditionally when we think about the symptomatology of AD, we think about the brain. However, recent discoveries that gut microbes could modulate brain function and behavior. Two, while most of the focus in the AD field have been either genetic or environmental factors associated with the disorder, the gut microbiome lies at the interface between the host and its environment. Moreover, GI symptoms and changes in gut microbial composition are common in the ASD individuals. 3. Regardless of the initial insult triggering the disorder and the extent of the alteration to the intestinal microbial communities, they found that L-Motorite reverses social deficits in genetic, environmental, and idiopathic models of ASD. Thus, their data supports the idea that microbial therapies could mitigate specific shortcomings in regards to ASD. And 4, given L-Motorite in several ASD mouse models and its safety profile, it would be interesting to examine whether it is able to improve social behavior in individuals with ASD in future studies.
For an empirical evaluation, this was only done on mice, and long-term effects of safety of manipulating gut microbiota were not addressed. I know there was a reservation in the sense of desensitization to oxytocin receptor was a thing. So there is a way in which, if let's say they manipulated too much, your brain would get used to the dosage and it would require a then greater amount to elicit the same effect. Boom, then you go ahead.
And these are the references that we got with that. But yeah.
Yeah, so first of all, I want to apologize because we didn't talk about your presentation feedback. So let's do that after we're done, right? We kind of skipped over, usually we're giving presentation
Oh,
feedback.
my God.
Yeah, sorry about that. I think we got caught up in all the discussion. So we'll do that,
It's not good.
we'll do it after, right? So, so where was this study published? I think I know.
I got it from Cell Press, but I don't think that's where it was published. Yeah, I go check.
But my point is that you can see that this type of study, it